Crossface Optimizer. Introduced in Release 7, and way back then, I remember it, like many DBAs, I thought it was pretty bad in Release 7. I realized as the years went by, when the Crossface Optimizer makes a mistake, it's usually my fault, not Oracle's. Worth remembering that. Now, the Crossface Optimizer calculates what it thinks is the fastest way to run the statement, based on I/O, disk I/O, memory I/O, and CPU requirements. It calculates the cost of the plan. The cost of the plan relies on statistics, information about the database, and its contents. And there may be several ways to run a particular statement, and that's what the optimizer looks at. Which way will be the best way to run that statement? Now, as an example, by the way, in our courses we normally use Linux machines. I'm just happen to be working under Windows today because it's a bit more convenient for this. As an example, let's have a look at our first execution plan. I'm going to use a facility. You don't need to take any notes at this stage because all will become clear after our break. But I'm going to enable the auto trace facility at this point. You'll see the syntax later on. Enabling the auto trace. And I'm going to run a simple statement, which is select star from emp natural join dept. Right. What did Oracle do? Well, back come the rows. And here's the execution plan. It did what we call a hash join to join the department table to the emp table. It chose that technique because it thinks there are 4 rows in dept, and it thinks there are 14 rows in emp. And for small tables of that nature, or tables of that, given any number of figures, Oracle has decided that hash join is the way to go to get the statement back, the result set back to the user as quickly as possible. And there you see the cost coming in. 3 cost units to scan emp, 3 cost units to scan dept. Therefore, the total statement, 6 cost units. Now, that's using the default optimizer mode of all rows. All rows. What if I change my optimizer mode? The all rows mechanism is the default, and many people don't like it. It develops a plan that will run the statement to completion as quickly as possible. Get all 14 rows back as fast as possible. I'm going to change optimizer mode to first rows and run the statement again. Back come the rows. Right. But it's a very different plan. What Oracle has chosen to do now is use, instead of a hash join, it's using nested loops, an iterative join structure. Instead of joining dept to emp, it's now joining emp to dept and using an index. Totally different plan. Totally different plan. And I may well have tuned my database just by making that one change. I've pushed the optimizer towards a different technique, one based on indexes. But look, the cost has shot up to 17. That's because the first rows optimizer mechanism constructs an execution plan that will get something back to the user as soon as possible, even if to get the complete result set back might take a bit longer. And this takes us back to what are you trying to tune? What are you tuning? What are your objectives? As a general rule, in this case, by the way, if it's anything to do with humans, you probably want first rows. So if it's an Apex application, a website or something, a forms application, that's probably what you want. Whereas if it's a data warehouse or a batch processing environment, well, then you'll probably want all rows. Oh, thank you for your comment, Pujit. By the way, when you make chat messages, please try to send them to the whole group. There's a button that lets you send messages to everybody. Otherwise, people only see sort of half the conversation. Now, these are the critical decisions the optimizer makes. Join order, join method, access method. The silver bullet of tuning is get the join order right. Oracle can join only 2 row sources at once. So if your query addresses 20 tables, do you join A to B to C to D? Or do you join A to D to B to see what order do you address the tables in, because Oracle can only look at 2 row sources at once. Having worked out the order, how is it going to do it? And you've already seen my little example here. The order has changed, and the method has changed from hash join to nested loop. And of course, in the full course, we have whole chapters on this. That's the second most important decision. Having worked out the order to join the rows, the tables, how are you going to join them? Having worked out how to join them, how are you going to implement that join the access method? And that typically will be full scan or index. But contrary to popular belief, that's the least important decision, and is usually driven by the earlier ones anyway. Hash joins are usually scan-driven, as you can see here, full table scans. Nested loops will generally be index-driven, assuming there's a suitable index. So those are the critical decisions, and we put some general rules here, but for heaven's sake, don't go away and say, John says that you should always join small to large. It's a lot more complicated than that. But these are general rules.